modification of a spermatid is what we call spermiogenesis. This is a process within spermatogenesis. Then, so that's spermiation that's occurring through here. Those are spermatids. Then, the release of a spermatid produces at least, it should be a mature spermatozoa. That release is called spermiation. We're not seeing it here because we don't see what's catching that cohort. You're not seeing the actual spermatozoa in the grasshopper. But starfish, it's visible. So if we skip forward, you'll be able to see that. I'm not going to quite skip that far forward yet. The main other thing about what we did last week was looking at the size comparisons. Primaries are big, secondaries are about half the size, and then it's going to go down even further in size and start to kind of go into these linear arrangements like that. You see that these are kind of becoming linear. That's spermatids. And then elongated spermatids down here. Yeah, I'm trying to make this stupid thing work, so just give me a second. It's the curtain's not blocked. It was nothing to do with the batteries, the curtain, or anything else. Homegirl unplugged my feed to plug in her jump drive. Yeah. Okay, so somebody asked about Pachytene. I don't know who it was. What we have here is two different stages of spermatocytes. And the reason that I know that there are definitely spermatocytes and nothing else versus like a spermatogonia or a spermatid. Number one, we can see I just replaced the batteries. There we go. Through here, that dark condensation of chromatin, it's either diplotin dikinetic or metaphase. That's not going to occur in spermatids. So that's your first clue that this would be a spermatocyte. Then you have cells. Then you have cells. This is a brand new battery and it's already fading. Then you have cells which are twice the size of these down here. Really, all through this. Things done. So these cells are nearly twice the size. So I would come to the conclusion that these would be secondary, these would be primary, because they're not different in morphology. They're both round. You can see chromatin, and you can see in here some kind of process is occurring versus a spermatid, where it would just be condensed and you wouldn't really be able to see individual chromosomes within it. So that's our designation. It's secondary spermatocyte and primary spermatocyte down here. Then you're going to look at the appearance of the chromatin within the nuclei of these cells. Now the cells are actually a little bigger than what's going on right here. There's going to be cytoplasm surrounding it, but the stain that's used, which is what? Hematoxylin, is selective for DNA. We're not going to have much DNA in the cytoplasm, so we're really just seeing the nuclei. For these cells out here, you're seeing nice squiggly chromatin. It's not condensed. Even if you think that it might be a little bit up here, it's not significantly condensed when we compare it to another slide. You'll see what I mean in a second. The cells are swollen. Most of them are pretty faint staining in the chromatin. So I'm going to call that pachytene. Pachytene is one of the 4 phases in prophase. We are only focusing on 2 of those prophase phases for now. We'll worry about the other ones when we get to the rat. The 4 phases are leptotene, zygotene, pachytene, which is here, and diplotene. Then it goes into metaphase. The first 3 that I mentioned, LZP, they're all going to look pretty similar, aside from the chromatin is going to kind of spread out a little more in pachytene. It's also, the nucleus is going to swell a little bit. So when you compare the 2 cells down the road, that's going to have the largest nucleus of all, pachytene. Why I'm not making the designation here is because it's too difficult. It's too difficult. It's really easy in the rat because we have a lot of different clues to draw the conclusion. We also have spatial indicators. If it's close to the wall of a tubule, close to the wall of the seminiferous tubule in the rat, we know a certain type of cell, and we can look at its appearance. Then we look at other cells in there and decide if it's leptotene, zygotene, all that stuff. Those are very particular. The reason we do that at all is because Dr. Stevens did his dissertation on rat andrology, and he finds it very interesting. So we'll be spending a little bit of time on that next week. Trust me, it will get more interesting. Okay, here. These right here look very similar to the ones on the last slide. That would be pachytene. The appearance of the nuclei through here, the chromatin is much more clumpy. It's darker, thicker, and less spread out throughout the nucleus. Fair? That will lead me to call this diplotene.